Hello everyone. I'm glad to see you back on my channel. Today we continue to exercise and practice practical part on any interview, especially on fun companies, for example, like Google. And today we will check a new task, which is called number of islands of medium type. And the idea of this problem is that we have a grid, in other words, matrix, representing an area where cells, each cell's value is either 1, which represent the land, or 0, which represent the water. And the borders of this grid, these borders, also are considered water. So we need to find how many islands exist in this area. And important notice here is that if two cells with value 1 are connected only diagonally, they are considered two separate islands. So for example, we have here an island 1 1 1, and let's imagine that here instead of 0 we also would have 1. It doesn't mean that this would be the same island, but it would be considered as separate islands, because this one would not be neighbor for this one. Yeah? If, for example, instead of here we would have one here, yeah, it would be a part of this island. So idea is that only cells connected horizontally or vertically counts as a part of the same island. So the logic of the algorithm which we will use in order to solve this problem is that we will need to check if a cell has value 1, and if so, we will need to increment the island counter because we have found a new island. Then we will need to check neighbors if they are also equal to 1. So for this cell we will need to check its neighbors, this one. So the neighbor from the right, the neighbor from the left, the neighbor from the top, and the neighbor from the bottom. And if for example we check the neighbor from the right and it's 1, we don't need to increment the counter because it's part of an island which we have already found. And also important thing here is that when we will reach the neighbor from the right, we will need to mark this cell as visited. Why so? Because if we will not mark it this like visited, we will reach this cell and then we will repeat the same process. So we will start to check the neighbor from the bottom, the neighbor from the right, the neighbor from the left, and neighbor from the top. And because here if we don't mark it like visited, it will create an infinite loop, which we want to avoid. So then, when we will do so, we will need to continue this process until there are not more ones left on the group, and then we again continue scanning the grid. And when we will find another one, for example, when we will reach this one, we will need again to increment our counter because it means that we have found another island. So that's the idea. Also, interesting thing here is that this grid you can imagine like a graph. So something like this. So we have a cell, and each cell has links to his neighbors. Yeah, and in that case we can use breadth first search, which we have already seen how it's working in the previous videos. But what does it mean? It means that we first recursively will start to check this neighbor, then the neighbor from the bottom, and then we will do the same for his neighbor. So we will go to the right, we will go to the down, here also we will go to the right, and so on. So that's the idea. I hope it's clear. If any questions, please write in the comments. But now let's check the implementation of this algorithm. So let's check the implementation for this method, and first of all, actually for this algorithm. And first thing which we want to do is to put a validation here first, just to check that grid is not equal to null, and that the length of this grid is not equal to 0, because if it is, we just can return 0. So let's put this condition: if grid is equal to null, or if grid length is 0, then in that case we can return 0. Perfect. So that's the first step. The second step, let's create two variables where we will store how much rows we have and how much columns in the row we have. So let's do this. Let's create two variables. Let's call first rows, grid length, and the second one we will call calls. And now let's create another variable which we will use like a counter, and we will store our result. So it will be actually let's call it land count, and initially it will be equal to 0. All right, and now we will need to iterate through our grid, and for that we will need to use two fors. One will be inner for. So let's do this. Let's create first for rows. We will iterate until row is less than rows. And we will need another one. We will need another one for columns. All right. So we have created our fors. Now we will need to check if the current cell, the value of the current cell is equal to 1. So let's do this. Let's check if the current cell, so grid rows and here calls column is equal to 1, like a char, because we have a grid of chars. Also it can be int, but in that case we have chars. So if it's equal to 1, then in that case let's increase our counter, land count, and also we can do it inside, but I prefer to create a separate method for that. We'll need a method which will help us to traverse in BFS our neighbors. So let's create this method. It will be private void BFS, and like argument here we will send first of all our grid, okay, grid, our row, and column. Perfect. And we will call it here. So the fs here we'll put the grid, the current row, and the current column. Alright, perfect. Now let's think about how we want to implement this method. So let's actually first of all create variables where we will store how much columns we have in grid and how much rows we have in this grid. So let's do this. So rows is equal to grid dot length, and calls grid dot length. Okay, perfect. So because we will call this method recursively, first of all we need to think when this recursion will stop, because if we don't have a good condition, it could lead to an infinite loop, which we want to avoid. And when we will stop our recursion, it will be in case if we go out of our borders, or if current neighbor, which we try to process, is not equal to 1. So if it's equal to 0, it means that it's not on land but it's a water, so we can stop to process and to return back. So let's put this condition. So first condition will be that we need to stop the recursion if row, so the index is less than 0, which means that we out of bounds, or if row is equal or greater than rows, and same, so the same thing, yeah, we are out of bounds, and the same thing we need to do for columns. Or in case if current element, so neighbor, is not equal to 1. So that's the condition when we want to return, when we want to stop the recursion, when we want to stop to process our neighbors. And now what we want to do, so first thing which we want to do, we want somehow to mark the current cell which we started to process and which we already visited, so we want to mark it like visited. And how we can do this? So we can just do something like this. So we take the current element and his value will become 0, and this will help us to avoid the infinite loop. Yeah, so because if we will go to the neighbor and then again we'll try to process the neighbors, and the neighbor will be the element for which we already passed, it will cause infinite loop. So by doing so, we mark that the current element already was visited, so the recursion will not happen. And now the most interesting part, we need to call this method, the fs, for all neighbors of the current element. So how we can do this? So we just call this method grid, and we call it for the neighbor from the top. We will call it for the neighbor from the down, from the bottom. And we will call it for neighbor from the left and from the right. All right, so that's the idea, that's the solution. But yeah, here we forgot to return the result. And now we have finished to implement this algorithm. So I hope it's clear. Now let's check the complexity. So the time complexity for this algorithm is OMN, and the space complexity is also OMN. So I hope this video was useful for you, and we will see you in the next one. Bye.